Hello everyone, if you installed SQL Server and Management Studio, click on Management Studio and this is what you will see, And I'm connecting. I used this Management Studio before, thus I do have some databases there, so let's look at the Object Explorer and click to expand the databases. System databases, don't change them, don't do anything with them. We will talk a little bit more about them. But this is our main example, and those are two other examples, and this is an example I did with a class last year. For most of this book, for much of this book, we're going to work with the AP database. AP stands for Accounts Payable, and as soon as you start consulting the book, you will see, you will read the description of what this database is. And in general, the rule about data, well, you need to know what's in your database. You need to know what kind of tables are there. You need to have a vague idea about the columns that are there. Otherwise, and you need to understand how this data is grouped and why. So to start doing that, I'm going to look at the vendors, right-click, select top 1000 rows. There is some auto-generated query to select top 1000 rows of our table. And here are those rows. Don't worry about this auto-generated query. Read the data. Familiarize yourself with data, because data is what your job is ultimately about when you do SQL or you do database administration. So vendor names, vendor addresses, this is all vendor information. Some of the values are null. Curious fact for you, nulls are not equal to each other. This null is not equal to that null and is not equal to that null unless you change some of the parameters in your session. But you don't need to do that. All right. So let's try another table, invoices, same trick, right-click, select top rows. Here is another table, invoice ID. They are all enumerated. ID is unique. Vendor ID is the number of the corresponding vendor. Like if we're going to look at vendor ID 123, we can go back to our other table, the vendors table, scroll down, where is my ID 123? That is Federal Express, and there are there is all the data, the address and the phone for the Federal Express. And first thing first, you may be asking yourself, why is this data split in two different tables instead of being just one large table? And the answer is, for example, reduce redundancy, reduce the size of this table. There is plenty of tables here, and throwing everything into one table will create a lot of redundancy of this kind. Now, the only reference to a vendor is this vendor ID. Imagine that in each row of the table, I would also include vendor name, which will be the same for all the highlighted rows, or also vendor address and vendor phone, and so on. First of all, it would be redundant and large, and second, it's not going to be that easier to work with, even for such small data. And really, this is a very small data. In reality, you will be working with gigabytes of data when necessary, or terabytes of data. So small data is nice because you can, if you like, actually go through and read each row and see how many nulls are there, how many zeros are there, what kind of values we are dealing with, and even squint at it and see that it's kind of consistent, or maybe not. In reality, you would have to do data cleaning and data wrangling and data manipulation and answer all kinds of questions. For example, for each vendor, what is the total invoices generated over a period, for example, from January to March? That would be a typical business question that can be answered with an SQL query. All right, so let me ask some easy question, natural question. Like vendor ID really doesn't tell anything to me. I want to see vendor ID. I want to see invoice date and invoice total to kind of see what's going on. Like which vendor generated, give me a name, and how much money. So I will need to somehow retrieve information from two tables, one that has vendor name for each of these IDs, and this one that has the invoice information. So I'm starting a new query, and I can just type it up. Don't worry what this means. And as soon as you start typing up, you will see that it's not easy to remember the columns that you want. Vendor name from one and the rest from the other. So here goes vendor name. Capitalized or not is not important. Vendor invoice total. I want invoice total. Invoice total. What else? And I want invoice date. Invoice date from vendors, join invoices. And how do I identify the columns from two different rows from two different tables? I'm going to identify them just like I did in my example by vendor ID, because this number corresponds to this number, vendor ID in the vendors table. All right, vendors dot vendor ID equals to invoices dot vendor ID. Okay, I'll start typing, and here it is. All right, let's try to run it. Whoops, that's not the one that I wanted to run. Let's try to run it. Here it is. So now I can see the name of the corporation, vendor name, and also I can see the invoice total and the date of the invoice, so I can get some information that somebody wanted. It's easier for me to read. And now this query is kind of ugly by itself, and also incidentally it changed the names of the columns accordingly. So we can improve on it and use this little trick from Design Query Editor to, first of all, make the query look nicer, and second, get the original column names over here. All right, let's rerun it. Here it is, and now the query is a lot more readable. Now, when they are automatically generated, they specify the name of the base and then dot the name of the column. This is not necessary except here, because vendor name is only one of the tables, and so is invoice total and invoice date. So this is an example for you how you can use queries and how you use databases. So databases manage data and store it in the relational databases in efficient way without much redundancy. I say much redundancy because there may be some redundancy, and it is up to you as a database administrator to organize the data well. And not gonna save any of this. Now, in case I don't like it, I can delete a database, I can detach a database, and I can attach a database. Now, first of all, let me just delete this database. I may have changed it somehow previously, so delete it. In order to delete it, you need to click on Close Existing Connections. All right. And now this database is gone. Well, just to repeat that, maybe I want to delete the other two. Not all of them, but the other two. Vlad is kind of custom made. Delete. All right. Now, if you've been installing Morich's, if you've been following the instructions, you also installed Morich's folder, not installed, but just copied March folder for SQL Server book 2016. And inside this book, there is some student downloads databases, create AP, and so on. So if you click on it, you should be able to open it directly with your management system, like this. Okay. And you can read this code, you don't have to understand everything yet, but create table is pretty self-explanatory. We're creating a table named this, and here we are creating the columns, and we specify some information about the columns. We can enforce the values not to be null, which is important, for example, for IDs, and so on. So we keep on creating some tables. This actually creates empty tables, just specifies the columns, the data types, varchar 50, that is a variable string of length no bigger than 50. Small date time, that is a date format, and money, and integer values, and so on. So that is what's happening in the script, and finally, we begin inserting values into our tables. This is actually inserting the values into the tables. And as we go on in our course, we will talk about all these commands, and it will be very clear for you what's happening. And in the end, you will be creating your own database with some sample values and relating different tables to each other. So there is some inputs with account numbers and some descriptions and so on and so forth. So this is, for example, our vendors table. So to insert into vendors table, we specify the column names and in the corresponding position. So vendor ID will always be first. Like here is vendor IDs. Vendor name will always be second. So if this tuple, starting from open parenthesis to close parenthesis, creates one row that will be inserted in our table. And there are some checks. So this could be actually a final project, something like a final project for you to create a database from scratch using SQL. But all we want to do, we want to run it. And I must have have changed something because it does not work. Line 454. Oh, accidentally, one good thing to know, if you highlight something and click execute, it will try to execute only the part that was highlighted. All right. Okay, so this is some output messages creating, doing something to the table, how many rows were affected. This is the vendors table that was created last, 122 rows. Okay, now we go back here and we refresh and we see our AP database, and now it is the original database. Now I did not have a chance to change anything here. So hopefully this is useful for you, and welcome to the class. Check out the details on chapters 1 and 2 now.